Here's a problem that you sent me. Find the derivative of a function. Said let y equal 2 over t. Find y prime. Well, we could agree on this, I think, using the limit process. We are looking for dy dt, aren't we? Dy dt is equal to the limit as the change in t approaches 0, right? This is, here's my little arrow, approaches 0, right? So this is what I'm going to do. I'm going to set this thing up. Yeah, actually, you know what? Here's what we're using the limit process. Here's what you asked me to use. Change in t minus f of t, right? All over change in t. So from here, I'm just going to just keep working this thing out. So here, I'm going to take the limit as the change in t approaches 0 of 2 over t plus change in t minus 2 over t minus change in t. All I'm doing is converting this to this, right? Because this is our definition up here, isn't it? So from here, look, this is just algebra now. This is where everybody gets all turned around. Here, I'm just going to multiply this side by t over t, right? Because I need a common denominator so I can add these two things together. And here, I'm going to multiply this by t plus change in t over t plus change in t here. Is that all right? I'm going to go ahead and do that, and this is what it's going to end up looking like, isn't it? It's going to end up looking like this. It's going to end up looking like the limit as the... If you're wondering, do you have to keep writing this notation over and over? Your professor is going to say yes, so I'm going to say yes. So t times 2 is 2t, isn't it? Minus, and then negative 2. See, this is a negative 2 here. Negative 2 times this, and then this is negative, negative 2t minus 2 changes of t, right? All over change in t, over t times t plus change in t. So far, so good? And then remember, we still have this crap down here at the bottom, so we have to, this is where I screw up all the time. I get so caught up in it. Then we have this whole thing over change in t. So I took this part at the top, translated it into this, so I got a complex fraction out of the deal, right? So from here, I'm going to look at this, and now this is a complex fraction. I mean, I'm going to take this thing this way, right? Multiply by the reciprocal. So I'm going to take the reciprocal of this, which is 1 over change in t. I'm going to simplify here. I'm going to simplify as much as I can. 2t minus 2t is 0. And here we have negative 2 change of t. The change of t's cancel out, don't they? So I'm going to keep rewriting if you don't mind. I'm going to get the limit as the change in t approaches 0 of negative 2 over, if I distribute into here, do I want to distribute into here? Oh, you know what I think I'm going to do? It won't hurt anything. What if I do this? What if I say, now I'm just going to let change of t equals 0. And if change of t equals 0, this would be 0. And it doesn't create any issue, does it? My studio is haunted. T times t is t squared plus 0. So here's our derivative. All right? So, oh, also on this, what did I want to remind you? On this, somebody asked me, like, how can you separate change from t? This is one symbol in the same way f of x is. So change of t is one symbol, okay? All right. I hope this was helpful. You guys did a good job. If you haven't already subscribed, please subscribe, and your comments are always welcome.